Let's continue on page 141 and do the rest of the problems on this page. Same idea. We are looking for the difference, meaning subtraction, of two squares. So reminding ourselves that really if we wanted to rewrite this, if we wanted a middle step in here, we could say, okay, this is x squared minus 5 squared. So this says, yes, indeed, I have the difference of two things that are squared. And the formula says this is a and this is b. So it's a plus b and a minus b. Over here, I have x is squared. I have a difference, and that becomes 9 squared. And that's where I got my a and my b. This is a and this is b. So when we come down to these problems, they have got a little bit more to them, some of them. Again, we're looking for the difference of two squares, and we're going to kind of throw another wrinkle in here with the GCF toward the end here. But if we notice that 4x squared can be written as 2 squared x squared, and 1, of course, can be written as 1 squared. So this 2x is all squared minus 1. This becomes my a, and this becomes my b. So my factored form is 2x plus 1 and 2x minus 1. If you look at b, this is 5a, all of that squared, minus 3b, all of that squared. So this becomes my a, this becomes my b, and I can write it 5a minus 3b, it's a b, and 5a plus 3b. Coming down here, now we're getting into ones that might end up having double factoring. I can see this as y squared minus 4 squared. So this is my a and this is my b. I can say y squared plus 4 and y squared minus 4. Now here's where the trick comes. You have another difference of two squares that you've just created. So when you are doing this factoring, you always want to factor completely. So you look and you ask yourself, do I still have another difference of two squares? And I do, because I have a y squared, I have a minus sign for a difference, and 4, of course, is a perfect square. So this can go a little bit further in the factoring process, and this will be your final answer. This guy. Let's look at this one. I've got two squares, an x squared and a 4, but I don't have a difference. So don't let this trip you up. Be very, very careful. We say this guy is prime because you can't take any, he has no common factors to take out of here. So you can't factor him. You can't factor further. He's done. All right, last two on the page. X to the 4th, y to the 6th. Okay, I can think of this as x squared, squared. There's the different sign. This is y cubed, squared. So here's my a, here's my b. So I have x squared plus y cubed, x squared minus y cubed. I ask myself, can I go any further? Well, I've got a difference here. X is a square, but y cubed is not. So I am finished. One last one. Here's the one I want to talk about, because on the very next page, we're going to talk about the first thing you look for in factoring is the GCF. That's always where you start, just like you look for distribution when you're solving equations. So we haven't had any that have a GCF to factor out at the beginning until this problem. But if you look at it, you've got a GCF of m to the 4th in both of them, in both of the terms, and n squared. So we are going to factor out the m to the 4th n squared. And when we do, we get 1 minus m to the 4th n to the 10th. And satisfy yourself that you can multiply back. That times 1 gives me himself. That times negative m to the 4th n to the 10th gives me 4 and 4 is 8, and 2 and 10 is 12. So I'm pretty satisfied now that I have the right factoring the GCF out. Now I ask myself, do I have the difference of two squares? And yeah, I do, because 1 is a perfect square. There's my difference sign. M to the 4th is m squared, and n to the 10th is n to the 5th squared. So I can go one more, m to the 4th, m squared, 1 minus m squared n to the 5th, and 1 plus m squared n to the 5th. Now, these aren't really written in standard form, because if they were, then our m squareds would be coming first. I'm not sure how important that is at this point. Just understanding that you can factor further is where I want to get you to be. And then if we need to clean this up and move this into standard form, we'll have to multiply through by a -1, and it would look a little bit different. But I think we're good to go for now. See you next time.